Jackson, what were you saying? You were saying that before I go on to the lesson, I should tell the students something? What was it? Here, come whisper in my ear and tell me, what were you going to say? Okay. Jackson says that at the end of today's lesson, other than the exit ticket that I'm going to ask you to complete, there's also going to be a review problem. And that review problem is going to be multi-digit multiplication. And we're going to ask you to go ahead and try your hardest. It's something we've already learned, to try your hardest to do it on your own and also return that review problem so we can see what you remember on your own and what we might need to teach over again and review. So just remember that'll be coming at the end too. Right, Jackson? Yeah, okay, right. Hello, fourth grade mathematicians. First, I just want to shout out and compliment you all on working so hard in math and in reading. And I've noticed on your math exit tickets, you've really been watching the videos as many times as you need to, following the instructions for your exit tickets, and then returning your exit tickets in a really thoughtful and complete way. So thanks for working so hard. Today's math learning target is I can find common numerators or common denominators to compare or order fractions. So let's break that down a little bit. So first they're saying find common numerators or common denominators. Let's think about what a numerator and denominator are and then talk about what common numerators are and common denominators are. So here's the fraction 3/5, and you'll notice that the word numerator is pointing to the 3 and the word denominator is pointing to the 5, and that's because in the fraction 3/5, 3 is the numerator and 5 is the denominator. I always like to start by thinking about a fraction by thinking about the denominator. So when I look at the 5, I know that I have a whole broken into 5 equal parts. And then I look at the numerator and I think, okay, and I have 3 of those 5 equal parts. And that can mean I have 3/5 of a candy bar, I have 3/5 of a drink left, but we often express that using a model. And you can see in this model that we have a whole broken into 5 equal parts. And remember, we're not computers, so we kind of make believe they look equal, even if they don't look exactly equal. And we have 3 of those equal parts. So this model represents the fraction 3/5. So now let's look at what we mean by common numerators. If we have a common numerator, it means that 2 or more fractions have the same numerator. And if we look at the numerator here, both 4/5 and 4/8 have a numerator of 4. So they have a common numerator. They have the same numerator. We're going to go over this in a lot more detail later, but it's really easy to compare fractions when they have the same numerator, because when you have a fraction like 4/5 where the whole is broken into 5 bigger parts, then you have a fraction like 4/8 where the whole is broken into 8 smaller parts. If you have 4 of those 5 bigger parts, it's going to be greater than 4 of those 8 smaller parts. That's why 4/5 is greater than 4/8. But again, we'll talk about that more later. Let's go on to common denominators. So here we're going to be talking about common denominators. Notice the fractions 2/6 and 5/6. Well, they have a common denominator because they both have a denominator of 6. And that means they have the same denominator. Another way of saying they have the same denominator is they have a common denominator. Just like when you have a common numerator, it's really easy to compare or put in order fractions that have the same denominator or have common denominators, because the whole, for example, here is broken into 6 equal parts in both fractions. So those parts are the same number of parts in the whole, they're the same size. And so if you have 2 of those 6 equal parts, it's going to be less than 5 of those 6 equal parts because, again, those parts are the same size. So hopefully this learning target's making a little more sense now. I can find common numerators, meaning I could find fractions that have the same numerator. When I say I could find them, it means if they don't already have the same numerator, I can figure out how to express them as equivalent fractions. So they do have the same numerator. And let's think about that because last week we learned how to express fractions as equivalent fractions. And then it also says I can find common denominators. And same thing, if they don't already have the same denominator, then I can express them as equivalent fractions with the same denominator. So I can easily, getting to the last part of the learning target, compare them, which is what I did here and here, right? If something's greater than, equal to, or less than, we're comparing them. Or I can order the fractions. And when I say order the fractions, it doesn't mean call up Uber fractions and have them delivered. It means I can put the fractions in order either from least to greatest or greatest to least. So we're comparing them. We're talking about 2. If we're ordering them, we're talking about putting 3 or more fractions in order from least to greatest or greatest to least. So we're going to have 2 really important rules that we have to remember for today's lesson. And here's the first of the 2 rules. So rule number 1 is if fractions have the same numerator, the fraction with the lesser denominator is greater. And that may sound weird, but it makes total sense when you think about it, and let's see why. Here's an example. So if we want to compare the fractions 2/4 and 2/8, they have a common numerator. For both fractions, the numerator is 2. So notice on the left, under 2/4, I've taken a whole, and I've broken it into 4 equal parts because the denominator is 4. And in the fraction on the right, 2/8, I've taken a whole and I've broken it into 8 equal parts because the denominator is 8. And notice that the fraction with the smaller denominator has bigger parts, and the fraction with the greater denominator has more smaller parts. And in each fraction, the numerator 2 tells us that we're going to shade in 2 of those parts. So notice when we do that, it's obvious that 2/4 is greater than 2/8 because I've shaded in 2 larger parts. And it's obvious that 2/8 is the smaller of the 2 fractions because I've shaded in 2 smaller parts. So think back to the rule we just mentioned. When we have 2 fractions with the same numerator, the fraction with the lesser denominator here, 2/4, is greater because the whole's broken into less bigger parts. And the fraction with the greater denominator is less because we have the whole broken into more smaller parts. So 2/4 is greater than 2/8. Again, here's the rule. If fractions have the same numerator, the fraction with the lesser denominator is greater. If fractions have the same numerator, the fraction with the lesser denominator is greater. So now we get to rule number 2. Rule number 2, if fractions have the same denominator, the fraction with the greater numerator is greater. Let's look at an example. 3/6 and 5/6. So they have common denominators. They have the same denominator, which is 6, which means that in both fractions, the whole is broken into 6 equal parts. And even though I didn't do this in my last example, it's a good idea to draw the wholes right next to each other. So for example, again, both wholes are broken into 6 equal parts. And I want to make sure when I'm comparing them that I don't do something like this, because if I drew models like this to represent 3/6 and 5/6, they're both wholes broken into 6 equal parts, but they're not the same wholes. They're completely different sizes. And when you're comparing fractions or doing anything with fractions really, you have to make sure you're comparing the same wholes, and these are not the same wholes. So You really want to make sure that you're very careful when drawing your models. Not that the models have to be perfect, but if they're not perfect, they should be not perfect in the same way. So here, when I have holes broken into 6 equal parts, even though my models aren't perfect, notice that the lines on each side match up. So when I go to finish comparing those two fractions, 3/6 and 5/6, I'll easily be able to see which one's less and which one's greater. Here, that wouldn't be true. I wouldn't be able to tell with my models. It wouldn't make any sense. So when we compare 3/6 and 5/6, two fractions with common denominators or the same denominator, we can see that in 3/6 we have a whole broken into 6 equal parts. The 3 in the numerator tells us that we have 3 of those parts, so we fill those in. And in 5/6 we have a whole also broken into 6 equal parts, the same size as the other fraction broken into 6 equal parts. But in 5/6 we have 5 of those 6 equal parts. So we can clearly tell that 3/6 is less than 5/6. 3/6 is less than 5/6. 3/6 is less than 5/6 because we have two fractions with the same denominators, and when we have two fractions with the same denominator, the fraction with the greater numerator is greater. That's rule number 2. If fractions have the same denominator, the fraction with the greater numerator is greater. You really need to remember both of those rules, and they also need to make sure they make sense. If you forget them, just draw two fractions, draw them with the same numerators for that first rule that we were talking about earlier, and see what makes sense. In here, draw them with the same denominators and see what makes sense. And here, of course, this rule makes sense for the reasons we just talked about. So if I ask you to compare 2/3 and 3/4, we can either find the same numerators, find common numerators, or find common denominators and then compare them. I think we'll do both, and I want to show you a strategy that I think works well for both ways. So first, I'm going to try to find a common numerator for 2/3 and 3/4 and then compare the fractions. First, I write the fractions above and below each other. Since we're working with the numerator, we're going to skip count. And our goal that we're trying to get to is to express these fractions as equivalent fractions with the same numerator. But the first step before we can do that is figure out what the common numerator should be, or what the same numerator should be. So the first thing I'm going to do is I'm going to skip count the numerators. So I'm going to take 2, I'm going to start skip counting, 2, 4, 6, 8. If it ends up that I don't find a common numerator, I could keep going. Then I'm going to take the 3 and 3/4, and I'm going to skip count 3, 6, 9, 12. And look at the numbers that we skip counted and see if you can find a number or a digit that's in common. And what I notice is both fractions have, let me say this a different way. When we skip counted the numerators of both fractions, we skip counted to 6, and that's a number that's in common with both fractions. So I'm going to circle that common numerator, that 6. And what that tells me is we're going to want to express 2/3 as a fraction with a numerator of 6. An equivalent fraction with a numerator of 6. And we're going to want to express 3/4 as an equivalent fraction with a numerator of 6. And one thing to remember is that when you're skip counting, you're really multiplying. So when I skip counted up here for 2/3, 2, 4, 6, 8, well, 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6, 2 times 4 is 8. So since we found that 6 would be the common numerator, that's times 3. And what that means is that in order to express 2/3 as a fraction with a numerator of 6, we're going to need to multiply 2/3 times 3/3, because that's going to give us an equivalent fraction to 2/3 with a numerator of 6. When we multiply 2/3 times 3/3, we find that 2/3 is equivalent to 6/9. So remember, that means that 2/3 and 6/9 are the same thing. And remember, whenever we multiply a fraction by another fraction with the same numerator and denominator, here like 3/3, we're going to get an equivalent fraction. But we knew to multiply by 3/3 because we were looking for a common denominator of 6. And because here we figured out that we needed to multiply the numerator 2 times 3 in order to come up with an equivalent fraction with a numerator of 6. So remember, we're comparing 2/3 and 3/4 by finding common numerators. Remember, we figured out that the common numerator we're looking for is 6. And so we've already worked through part of 2/3. Let's look at 3/4. And for 3/4, we're going to use the same strategy to find an equivalent fraction with a numerator of 6. So what we did is we skip counted. We figured out we want to express 3/4 as an equivalent fraction with a numerator of 6. And look at 3 times 1, 3 times 2 is 6. And that tells me I'm going to want to multiply 3/4 times 2/2, or 2/2, in order to express it as an equivalent fraction with a numerator of 6. When I do that, I see that 3/4 is equivalent to 6/8, or in other words, 3/4 is the same thing as 6/8. And now that I've expressed both fractions as fractions with numerators of 6, I can compare 6/9 and 6/8 using the rule that we learned that when we have two fractions with the same numerator, the fraction with the smaller denominator is greater. When I do that, I can figure out that 6/9 is less than 6/8, because when you look at 6/9, that means that our whole is broken into 9 smaller parts. When you look at 6/8, it means that our whole is broken into 8 bigger parts, because there's less of them and they're bigger. And so 6 of those 9 smaller parts is less than 6 of those 8 bigger parts. And next, we want to express 6/9 as its original equivalent fraction, and same thing with 6/8. So we go back and we see that 6/9 is equivalent to 2/3. If you say 2/3 is equivalent to 6/9, you can also say 6/9 is equivalent to 2/3. So under 6/9, we're going to write 2/3 because they're the same thing. So there I wrote 2/3 under 6/9. And now we want to figure out what we're going to write under 6/8. Well, 6/8 and 3/4 are equivalent. So I'm going to write 3/4 under 6/8 because 3/4 and 6/8 are the same thing. So since 6/9 is less than 6/8, and 6/9 and 2/3 are equivalent, and 6/8 and 3/4 are equivalent, then 2/3 is less than 3/4. So now, going back to the original fractions that I was asked to compare, I just figured out that 2/3 is less than 3/4. Now I can use the same exact strategy to find common denominators and then compare the two fractions. So the first thing I'm going to do is write 2/3 and 3/4 above and below each other. I'm going to skip count the denominators until I find a common denominator. I'm going to circle that common denominator, figure out what I need to multiply each fraction by to get an equivalent fraction with the same denominator or with common denominators, and then I'm going to compare them. So here I took 2/3, focused on the denominator 3, I skip counted it, 3, 6, 9, 12, 15. I took 3/4, focused on the denominator 4, I skip counted it, 4, 8, 12, 16. I could have kept going, but what I saw here was that I got to 12 with each of the denominators. And so that's going to be the common denominator that I'm going to want to express each of these fractions at. Or in other words, I'm going to want to express each of these fractions as equivalent fractions with a denominator of 12. For 2/3, I see that I had to multiply 3 times 4 to get the denominator of 12. And with 3/4, I saw that I had to multiply 4 times 3 to get the denominator of 12. So for 2/3, I'm going to multiply it by 4/4 to find an equivalent fraction with a denominator of 12. And for 3/4, I'm going to multiply it by 3/3 to find an equivalent fraction with a denominator of 12. So that's what I did right here. I see that 2/3 is equivalent to 8/12 and 3/4 is equivalent to 9/12. Now I'm going to compare that 8/12 and 9/12, and then I'm going to express them back as their original equivalent fractions of 2/3 and 3/4. So 8/12 is less than 9/12 because our rule is that when you have the same denominator or when you have common denominators, the fraction with the smaller numerator is less than the fraction with the greater numerator. And again, that's because in both fractions, the denominator is broken into 12 of the same sized parts. And if you have 8 of those same sized parts, that's going to be less than 9 of those same sized parts. If 8/12 is less than 9/12, that means that 2/3 is less than 3/4 because we figured out earlier that 8/12 was equivalent to 2/3, that 8/12 was equivalent to 2/3, and that 9/12 was equivalent to 3/4, and that 9/12 was equivalent to 3/4. So that means if 8/12 is less than 9/12, then they're equivalent fractions. 2/3 is less than 3/4. And let's see if our results are the same or consistent with what we got when we found common numerators to compare fractions. So when we found common numerators, we had figured out that 2/3 is less than 3/4, and now that we found common denominators, we also see that 2/3 is less than 3/4. So we got the same result. So now I want you to try to compare these two fractions using the same strategies that we just tried. So first you'll compare them by finding common numerators and then expressing both fractions as equivalent fractions with the same numerator. Then you'll go back and you'll compare them by finding common denominators and expressing both fractions as equivalent fractions with the same denominators, and then compare them. So go ahead and pause the video, and then when you come back, we'll go over both strategies together. Go ahead and pause the video and try it. Okay, so I asked you to compare 2/8 and 5/12 first by finding common numerators. So we write 2/8 and 5/12 above and below each other. We skip count the numerator in 2/8, 2, 4, 6, 8, 10. We could keep going. We skip count the numerator in 5/12, 5, 10, 15. I notice that I see that we're going to want to express both fractions as fractions with numerators of 10. To do that for 2/8, to find an equivalent fraction with a numerator of 10, I'm going to need to multiply it by 5/5, because when I skip counted 2, 4, 6, 8, 10, I see that I have to multiply 2 times 5 to come up with a numerator of 10. And when I skip counted 5/12, I see I need to multiply 5/12 times 2 halves to find an equivalent fraction with a numerator of 10. Here I've done that, multiplied 2/8 times 5/5, found the equivalent fraction of 10/40. So 2/8 is the same as 10/40. And I did what I said I was going to do by multiplying 5/12 by 2 halves. to find the equivalent fraction of 10/24. So 5/12 and 10/24 are the same thing. Now I can compare 10/40 and 10/24. When I do that, I see that 10/40 is less than 10/24. So 10/40 is less than 10/24 because if we have a whole broken into 40 smaller parts compared to a whole broken into 24 bigger parts or greater parts, 10 of the smaller parts in 10/40 is going to be less than 10 of the bigger parts in 10/24. So when you have the same numerator, the fraction with the greater denominator is lesser. So 10/40 is less than 10/24. Since 2/8 is equivalent to 10/40, we write 2/8 under 10/40 because they're equivalent fractions, same thing. And since 10/24 is equivalent to 5/12, we write 5/12 under 10/24. And if 10/40 is less than 10/24, then their equivalent fractions work the same way. So 2/8 is less than 5/12, and 2/8 is less than 5/12. So now we want to compare those two fractions by finding common denominators. So when we skip counted the denominators in 2/8 and 5/12, we see that we can express each of those fractions as equivalent fractions with a denominator of 24. In 2/8, we skip counted 3 times to get to a denominator of 24, which means that 2/8 times 3/3 will give us a fraction with an equivalent fraction with a denominator of 24. In 5/12, we skip counted 2 times to find the denominator of 24, which tells us that when we multiply 5/12 times 2 halves, we'll get the product as an equivalent fraction with a denominator of 24. Once both fractions are expressed as equivalent fractions with denominators of 24, we can easily compare them using the second rule that we learned. So when we do that, 2/8 times 3/3 is equivalent to 6/24, and 5/12 times 2 halves is equivalent to 10/24. We can now compare 6/24 and 10/24. 6/24 is less than 10/24, partly because the rule is when you have the same denominator, the fraction with the smaller numerator is lesser. But also we can think about it, and our whole in both of those fractions is broken into 24 equal parts of the same size. So if you have 6 of those same size parts, it's going to be less than 10 of those same size parts. So 6/24 is less than 10/24. 6/24 is equivalent to 2/8. So let's write the 2/8 below the 6/24. And 5/12 is equivalent to 10/24. So let's write the 5/12 under the 10/24. If 6/24 is less than 10/24, then 2/8 is less than 5/12, because 6/24 and 2/8 are equivalent fractions, and 10/24 and 5/12 are equivalent fractions. And finding that 2/8 is less than 5/12 by expressing those fractions as fractions with equivalent denominators gives us the same result that we had before. 2/8 is less than 5/12. Okay, now we're going to use the same strategy to order fractions from least to greatest. Here we have 3 fractions. We're going to do that by finding common numerators, figuring out which fraction's the least, which one's in the middle, and which one's the greatest. And then we'll do it by finding common denominators and doing the same thing. I'm going to model it by finding common numerators. When we get to common denominators, I'm going to have you try it on your own and then come back and check it against our work. So first I'm going to model it finding common numerators. To do that, I'll write 2/3, 5/6, and 1/4 above and below each other. I'll skip count the numerators till I find a common numerator, and we'll go from there. So this time I needed to find a numerator that I could express all three fractions with common numerators. And so I skip counted the numerators in all three fractions until I found a common numerator, and here that common numerator is 10. So notice for 2/3 I skip counted 5 times. For 5/6 I had to skip count 2 times, and for 1/4 I had to skip count 10 times. So since I skip counted 2/3 5 times, that means I have to multiply 2/3 times 5/5. Got the equivalent fraction of 10/15. So 2/3 is 10/15. When I skip counted 5/6 2 times, it means I had to multiply 5/6 times 2/2, or 2/2. Got the equivalent fraction of 10/12, which means 5/6 is 10/12. And when I skip counted 1/4, I had to skip count the numerator 10 times, which means I have to multiply 1/4 times 10/10, and got the equivalent fraction of 10/40. So 1/4 is 10/40. Now I'm going to line up 10/15, 10/12, and 10/40, and think about, now that they have common numerators, I'm going to reason or think about their size and what order to put them in. So when I do that, when I line up 10/15, 10/12, and 10/40, I remember when we have common numerators, or when we have the same numerator, the fraction with the smallest denominator is the greatest, and the fraction with the largest denominator is the least. So the least fraction here is 10/40, because 10/40 has the greatest denominator. The greatest fraction here is 10/12, because 10/12 has the smallest denominator, and the one in the middle is 10/15. So what I did is I put 1, 2, 3 above them, so I can remember that I need to order them from least to greatest. And now I'm going to actually put them in that order. So you can see right below, I put them in order from least to greatest: 10/40, then 10/15, then 10/12. And now I'm going to go ahead and express 10/40, 10/15, and 10/12 back as we originally expressed them. So 10/40 was equivalent to 1/4. 10/15 was equivalent to 2/3. And 10/12 was equivalent to 5/6. So now I've taken the three fractions that I had in the beginning, which were 2/3, 5/6, and 1/4, and I put them in order from least to greatest: 1/4, 2/3, then 5/6. So now I want you to try the same thing by finding common denominators and see if you get the same order from least to greatest. So I want to see all your work. I'll start you off. I took 2/3, 5/6, and 1/4. I put them above and below each other, and now I'm going to start skip counting denominators and then follow all those steps. So pause the video, go ahead and try it yourself. Pause it now, and then we'll come back and I'll show you what we should have done. So what we should have done is skip counted the denominators in each of those three fractions until we found the same denominator. Recognize that we should multiply 2/3 times 4/4 to find an equivalent fraction with a denominator of 12. That we should have multiplied 5/6 times 2/2 to find an equivalent fraction with a denominator of 12. And recognize that we should have multiplied 1/4 times 3/3 to find a equivalent fraction with a denominator of 12. So 2/3 is the same as 8/12, 5/6 is the same as 10/12, and 1/4 is the same as 3/12. Then we should have written those three fractions as their equivalent fractions, and then reasoned that because they all have the same denominator, the fraction with the smallest numerator is the smallest, so 3/12. I put a 1 above it just to show it's the smallest. Then 8/12 is in the middle, so I put a 2 above that. And then 10/12 is the greatest, because that's the greatest numerator, and they all have the same denominator, so I put a 3 above that to show that. Then I actually put them in that order, so I put 3/12 is the least, then 8/12, then 10/12 is the greatest, and then just express them as their original equivalent fractions, 1/4, then 2/3, then 5/6, which is the same result we got when we found common numerators in order to put the fractions in order from least to greatest. So for the first part of your exit ticket, I'd like you to compare 4/6 and 3/8. First, by using the same steps that we've already shown to find common numerators, express them as their equivalent fractions, compare them, and then express them just like as they are with a less than, equal to, or greater than sign. And then do the same thing by finding common denominators using all the same steps that we've just demonstrated. So the second part of your exit ticket is to put these fractions in order from least to greatest by first finding common numerators, showing all the same work that we did when we did that with other fractions in the earlier part of our lesson, and then do the same thing by finding common denominators. So first I want you to find common numerators to order these fractions from least to greatest, then find common denominators to order these fractions from least to greatest, showing all of your work and all of the steps that we went over in this video. And finally, the review problem that I want you to try on your own to see what you remember, because we've learned this, is to use any place value strategy to find the product, or in other words, to multiply these numbers. You're going to be multiplying 4,382 times 5, and just as a reminder, place value strategy means partial products multiplication or area model multiplication. So you're going to use either partial products multiplication or area model multiplication to find the product of 4,382 times 5.